Hello, welcome to the start of lesson 5.1 or unit 5, Lewis dot diagrams, where we're going to talk about molecular structure. So your two goals in this lesson, in your notes, make sure you have your title and the two key ideas, know what a Lewis dot diagram is and how to draw one. So in this unit, we're going to talk about how the structures of molecules form and how we can use molecular structure, basically the shape when atoms combine together form a molecular structure, right, in order to identify new potential viruses. So the way viruses work is each type of virus often has a different shape, and these shapes are basically just a combination of atoms forming a molecule together. And viruses have a way of hacking into our cells because basically they figure out what shapes allow them to enter our cells. So if our body cell has this shape, right, the virus will mimic this particular shape kind of as a key to get inside of our cell, right? So viruses do this often by mutating themselves, and then one will randomly fit into our body. And that's how we end up with a brand new virus that we might not have seen before, right? There are also other uses to understanding molecular structures, such as changing your hair from curly to straight or straight to curly, right? So oftentimes, if you have straight hair, the proteins in your hair called keratin look like this particular shape, right? So they're bonded straight across or they're combined straight across, right? And that causes your hair to be straight. When you add waving lotion and a neutralizer, or sometimes called an oxidizer, right? You're breaking those specific bonds or the way your hair combines in order to get these curly strands, right? So however many disulfide bonds you have, that's basically what the name of these bonds are called, or how many hydrogen sulfide bonds you have, like these ones, will alter how straight or how curly your hair is, right? So oftentimes at the salon, they use different methods to do this, right? Either through heat treatments or acid treatments or cold treatment. There's different ways to both relax and curl your hair, right? And that has to do with the same type of chemistry of understanding how, when atoms combine, what shapes do you get and how you can manipulate that. Another thing that it's useful for is to identify different foods and flavor combinations that are kind of weird, right? So oftentimes in molecular gastronomy, which is basically like food science, right? Understanding how to manipulate taste, flavors, or smells if you're thinking about perfumes and odors and things like that. If you look at the molecular structure of smells that tend to go together, their shape tends to be very similar. So this first one is the primary odor and flavor for vanilla. This one is for cinnamon, and this one is for almond and cherries. So almond and cherries actually have the same exact structure, and that's often why when you make a cherry pie recipe, the recipe will call for almond extracts as an additional flavoring to make it smell more like cherries, because it's actually the same exact molecule, right? And there are secondary molecules that allow your body to differentiate the difference between almonds or cherries, but if you isolate the odor, they're actually the same thing, right? So if you understand how the shape of different food molecules are similar, you can come up with kind of odd and interesting pairings of flavors that tend to work, right? So honey and garlic is a common one, right? Honey and garlic go together because they also have molecules that are same shapes. Fish sauce and caramel, kind of a weird one. Jalapenos and peach, carrots and coffee, beets and cocoa or chocolates are all types of foods that have very similar primary shapes of their molecules. that cause them to like taste good together, even though they sound like really weird in terms of a combo. So if you ever try these, let me know in Zoom class if you like them or not, or if it works for you or not, and why. So in this lesson, we're going to talk about how do we figure out what shapes different elements are going to form when they combine together, so that we can learn more about food flavor combinations that are kind of weird but also work, and or if you're interested, different types of hair curls and how to manipulate that, and also how new viruses are formed, right? So we first need to understand, how do we figure out the shape of different elements? And to do that, we need to learn about something called Lewis dot diagrams. So Lewis dot diagrams are basically these images in bolded black over here, right? And it's a model of the elements only showing their valence electrons, right? So make sure you have this in red in your notes. This you don't necessarily need, right? So just this part over here. So recall that if you're in group 1A, all of these elements have one valence electron. And if the Lewis dot diagram is only showing the valence electron, you only need to show one dot, as it shows here. Okay, so these are the two steps on how to draw a Lewis dot diagram for each element. So step number 1 is to identify the number of valence electrons an element has using their group number. So recall that whatever number next to the letter A, that group number is, that's how many number of valence electrons you need to draw. And secondly, to draw them, the order of the dots go like this. So first dot, second dot, third dot, fourth dot, fifth dot, sixth dot, seventh dot, eighth dot. So let's do an example here. So draw the Lewis dot diagram for lithium, or Li. So the first thing I need to do is to figure out how many valence electrons lithium, or Li, has by going to tinyurl /quantptable.com, right? Or this site's over here. Most of the time I'll link this for you so you don't need to search it up. So the next thing I need to do is look for lithium, right? So going across, lithium is here, Li, right? So it is in group 1A. Therefore, I know that I'm going to need to draw one valence electron. So in step number 1, it's in group 1A, so I need to draw one valence electron. So using this X as an example, if I just need to draw one, I'm going to draw the symbol Li for lithium, and then one dot up top, right? So that's this one over here. Notice that in this example, it's drawn to the right, and that's okay, right? So, or Li this way. You could also draw it at the bottom, right? But I usually start following this model, starting from the top and then working my way clockwise and then back around again. So all three of these, actually there could be one more option, so let me just draw that. All four of these answers could be correct. Right, so either draw it like this, this, or this. So let's do a little bit of a trickier example, drawing the Lewis dot diagram for nitrogen, or N. And let me do that in purple. So same as before, I'm going to go to the periodic table, right, or this site right here. It'll usually be linked for you. And then I'm going to look for nitrogen. So I'm basically looking for the letter N, which is here, or the name nitrogen, right? So if I see nitrogen -N, looking for nitrogen, it is in group 5A. So that tells me I need to draw 5 dots. So 5A is 5 valence electrons, meaning I need to draw 5 dots. right? So again, in the center will be my element symbol, so just the letter N. So whatever it says after the dash, right? I'm going to use this to help me follow the order. So I'm going to need to draw 1, 2, 3 dots, 4 dots. So 4 is this one. And then the 5th dot, I'm going to go back around on top, right? And the reason why we have to draw it this way is because later on, when we combine these single dots tell us how the structure will form, right? So make sure you always follow the order of first dot, second dot, third, fourth, fifth. So basically you go clockwise twice around, right? So my Lewis dot diagram for nitrogen will look like this. So at this point, you should be able to do the next couple of practice problems on your own.